continuing on with example number 12, we have our first rational function here, where we have 4x minus 5 over the quantity 2x squared minus 5x plus 1. Okay, so where do we go with this one? Because we're not multiplying like we are in example 13 or some of the previous examples. And again, we're trying to identify that inner function so that we can work off of that. So if we think back to our derivatives and our antiderivatives, remember 1 over x? That led us to natural log. And when we were deriving the natural log involving the chain rule, so we had the natural log of something more than x, and we took the derivative, we put the derivative of the inner function in the numerator and the original function in the, or extension, in the denominator. Okay, remember there was no natural log in our actual derivative. And that's what's happening right here. All right, we have our u is going to be our denominator. And watch what happens when we derive it. So we make u equal to 2x squared minus 5x plus 1. Hopefully that stayed on the screen. Just about. There's a 1 right there. Let's make it a little softer. There we go. Plus 1. And we want the derivative of that. So du is going to be 4x minus 5 dx. And lo and behold, that's exactly what we have in our numerator, a 4x minus 5 and a dx. What a coincidence again. All right, these are set up in this way in order for us to find these antiderivatives. If that wasn't there, we'd have to go with something else. Okay, and we'll talk about that more in a moment. But right now, we have the ability to make our substitution. So what do we have? We have the antiderivative. 4x minus 5 and dx are in the numerator. They are going to be subbed out. Du is going to sub in. In the denominator, 2x squared minus 5x plus 1, that's u. So now we have du over u. Okay, again, that was the result when we derived the natural log of an inner function. Now we're doing the antiderivative of the fraction, which means that the antiderivative will be the natural log of the absolute value of u plus c. Okay, and again, if it helps, you can think of this as 1 over u du. All right, replace that with the u's with x's. You have 1 over x dx. Hey, we already know that antiderivative. So whether it's 1 over x, 1 over u, or 1 over something else, the antiderivative is going to be natural log. Again, final step, we're going to put u out, and we're going to put 2x squared minus 5x plus 1 back in. Make those absolute value markers a little bit larger. And there's our final answer for example number 12. 13, we see 3x squared plus 2, and it's in parentheses, but that's not going to be our inner function, because after that we see e to something more than x. Okay, there's our chain rule happening. All right, the inner function is actually the exponent. All right, so we're going to make u equal to that exponent. All right, so u is x cubed plus 2x minus 4, and when we derive that, we get 3x squared plus 2 dx. All right. Lo and behold, 3x plus 2 right there. So the 3x plus 2 and the dx, they're going to sub out, du is going to sub in, and so is our exponent. So we have the antiderivative of e to the u du. That's nice and easy to do. We like that antiderivative because that just becomes e to the u plus c. And now we can just replace u with what u is equal to, which is that x cubed term. When we do so, right, we have e to the x cubed plus 2x minus 4 plus c. Guess what happens when we derive that? We're going to get, if there's a plus c, you can't see the c, it's off the screen, I apologize for that. When we derive that, we've got ourselves our original problem there in green.